Hello viewers, let's start the exploration of beta integral and its various forms. We have defined beta integral by beta mn is equals to 0 to 1 integration x to the power m minus 1 minus x to the power n minus 1 dx. Now this is beta integral, and beta integral is symmetric. That means beta mn is equals to beta nm. How we can prove this? So for proof, this is our equation 1. Replace x is equals to 1 minus y in 1. So the rule of changing variable in integration is that if you change the variable, you also change the limit and also change this dx part. So where the dx comes from? From this definition, dx will be 1, the differentiation of 1 is 0, differentiation of y is dy, minus sign is there. Again, for limit, if x is equals to 0, then y will be 1 minus 1 is 0. So if x is equals to 0, y is equals to 1, and if x is equals to 1, then y must be 0. So our integral in 1 becomes what it becomes. Let us write it here. Beta mn is equals to, replace 1 by 1. What is the replacement? Replacement was x is equals to 1 minus y. This means 1 minus x is equals to y. Limits are, what are the limits? They are reversed, because when x is equals to 0, y is equals to 1. And when x is equals to 1, y is equals to 0. X is 1 minus y. So there is power of m minus 1. And again 1 minus x is y. So y to the power n minus 1. Dx is equals to minus dy. So this minus comes outside. My 1 to 0, we can write it as y n minus 1. 1 minus y m minus 1. And this is dy. And again, this becomes, if there is minus sign, the limit will be reversed. So it will give 0 to 1, y to the power n minus 1, 1 minus y to the power m minus 1 dy. So if you compare these two definitions, and remembering that variables are dummy, that means inside the function matters and the limits matter. So if you compare this, this is x to the power m minus 1, y to the power n minus 1. 1 minus x to the power n minus 1, this is 1 minus y to the power m minus 1. Dx is there because this function is of x, dy is there because this is function of y. So if we write m minus 1, n minus 1, beta mn, so we can write n minus 1, m minus 1 is equals to beta nm, which proves the definition that beta mn is equals to beta nm. This means beta integral is symmetric. So similarly, we can show by some replacements and changing the variables, we can show that beta integral can also be written as beta mn is equals to 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. Also, we can show beta mn is equals to 0 to infinity. Here it is 0 to infinity. X to the power m minus 1 upon 1 plus x to the power m plus n dx, and also by the symmetry property 0 to infinity x to the power n minus 1 upon 1 plus x to the power m plus n dx. So these are the various forms of beta integral. Thank you for watching. Keep practicing. Good luck.